Hello and welcome to the Hydraulics of Tomorrow. My name is Alexander Bosch. I'm responsible for product management at Voith Hydraulics in Rüdesheim, Germany. Together with our technical manager and managing director, Bert Bramer, I have the pleasure of introducing you to the world of Voith servo drives today.
Thank you, Alexander, and welcome to all participants. In industrial hydraulics today, we see three main approaches to controlling pressure and flow. The standard approach, an asynchronous motor that drives a fixed displacement pump. A first improvement, use a variable displacement pump to adjust the oil flow. And finally, use a variable speed servo motor with a fixed displacement pump. Now, how do these approaches differ? And what are their advantages and disadvantages? Let's take a closer look at that. We start with the system of asynchronous motor and fixed displacement pump. Here, an electric motor fed directly from the mains drives the pump at a constant speed. The fixed displacement pump thus provides a constant flow of fluid. An accumulator charging circuit or a pressure limitation valve provides for a constant pressure at the inlet of the control valve. That is not shown here for simplicity. The directional control, as well as control for pressure and flow rate for the actuator, are made using a proportional valve. The hardware investment cost for such a system is generally lower than for other solutions. However, the life cycle costs are comparatively higher due to the high energy consumption. The advantages of this approach are using well-known technology and the dynamics that can be realized. In contrast, the disadvantages are noise emissions due to the continuous operation of the motor, high cost for the valve technology, and the high energy consumption due to throttling losses in the proportional valve. Now to the asynchronous motor with variable displacement pump. Variable displacement pumps are also often driven by asynchronous motors at constant speed. Here, the directional control valve is only used to pre-select the direction of movement. The pressure and the flow rate are now controlled by a variable displacement function, for example, of an axial piston pump. As a result, this improves the energy efficiency of the system. But still, there are considerable energy losses and noise. The advantages of this approach: higher energy efficiency compared to the asynchronous motor with fixed displacement pump, compared to the disadvantages, which are significantly higher cost for variable displacement pump, energy loss due to operation of the asynchronous motor at partial load, and still high noise due to emissions because of the continuous operation of the engine. Finally, let's look at the synchronous servo motor with a fixed displacement pump. These servo hydraulic drives combine the advantages of hydraulics with the benefits of servo drive technology. Hydraulics stands for high power density, robustness, and overload resistance. Servo drive technology contributes good efficiency, precision, and easy commissioning. Because the motor only runs when the axis is active, there is no noise during pauses. In this context, we talk of power on demand. This picture shows a system with a valve for direction preselection. This is often used when a single motor pump unit is used to actuate several actuators. For single axis, there are also circuits that do not require any valves at all. In this case, the direction is controlled via the direction of the rotation of the motor and pump, which will then also be shown accordingly in the circuit diagram. To give you a better understanding of the functional principle of servo hydraulics, we have brought along a short video. That covers a lot of basics and theory. With that, we are now ready and curious to dive deeper into the world of motors, pumps, and systems. Please, Alexander.
Here we go. As we just heard and seen, the combination of hydraulic power transmission and servo technology results in an energy-efficient system, a so-called servo hydraulic system. In the technical world, the terms that come up in connection with servo hydraulics are often not clearly defined. We at Voith always speak of a servo hydraulic drive as a variable speed pump drive driven by a speed-controlled motor, in other words, a servo motor. To make life easier for you and for us to distinguish between these products, we have decided to combine them into one joint product family. Now, you will surely ask yourself what DrivAx means. The word DrivAx is composed of the English terms drive and axis. However, the family of DrivAx drives not only includes complete servo hydraulic axis, the combination of a variable speed pump and a servo motor will also be part of the DrivAx family. In short, all drives based on the principle of a hydraulic variable speed pump with speed-controlled motor belong to the DrivAx family. I would now to explain what these are in detail based on our product development history. The foundation for the development of the DrivAx family was laid in 2002 with the development of the DrivAx IPS. It consists of a servo motor and a variable speed internal gear pump. Thanks to its low mass moment of inertia, the motor-pump combination enables highly dynamic control of the process. In conjunction with precise control, we can reduce process times up to 50% and thus significantly improve the productivity of the machine and the whole system. But we will hear more about this later. Let's continue with a close relative to the DrivAx IPS, the DrivAx PSH. While the DrivAx IPS is available as a motor-pump combination for various system configurations and applications, the DrivAx PSH was composed specifically for presses. Thanks to the scalable modular design, tonnages from 50 to over 1,000 tons can be realized. In addition to the drive, we also offer you the entire automation. So all in all, the high precision with which our DrivAx PSH can be controlled and regulated allows us to carry out the position control down to hundredth of millimeter. In 2012, the DrivAx CLDP was introduced to the market, and with it, the world's first self-contained servo drive. At the heart of the system are two internal gear pumps whose volume flows are matched to the area ratio of the differential cylinder. In addition, there is an intelligent control system with field bus connection, a pressure fuse, and a small expansion tank. This closed-loop design eliminates the need for valves and piping. As a result, the system is extremely compact and is ready for operation as soon as the servo motor is connected. The DrivAx CLDP is our flagship in the field of servo hydraulic drives and has already proven itself in various applications thanks to its versatility. While the DrivAx CLDP was a representative of the versatile drives, in 2014 we came back to a representative of the application-specific drives, the DrivAx CSH. The DrivAx CSH is a cushion drive consisting of a variable speed motor pump combination and a double-acting cylinder. The advantages of combining a DrivAx CSH and a DrivAx PSH for the user will be discussed in more detail in the further course of our presentation. The next drive, the DrivAx PDSC, that was launched in 2014, is also a self-contained drive. With load-dependent switching between rapid traverse and load traverse, we can reduce the electrical connected load compared to the DrivAx CLDP, for example. As a result, the size of the motor and the inverter can be reduced, which not only makes the purchaser happy, but also achieves higher energy savings and in turn benefits the end user. In addition to the drive, we also offer the complete system here, so that the user can program processes, parameters, and load profiles easily and quickly. The self-contained DrivAx CLCP is the result of consistent further development of the DrivAx CLDP. Here, we also see the cycle-controlled load switching of the hydraulic transmission. This allows us to build compactly and also reducing weight. Thus, the DrivAx CLCP is perfectly suited for all robot-assisted applications, as well as enabling the efficient automation of bending, cutting, and molding processes. The built-in sensor technology provides you with the basis for complete integration into your automated manufacturing or production system. So now we see the entire development history of Voith DrivAx drives listed here. Why are we showing you our product development history and products which you already know? The timeline shows quite clearly that Voith has over 20 years of experience in servo hydraulic drive systems. We are not only a pioneer, but also the market leader in the field of self-contained compact axes. We are keen to help you getting started with the servo hydraulic drive technology, the hydraulics of tomorrow. But many of these products are probably already known to you, and that alone, of course, is not why we are here today. So last but definitely not least, we proudly present the newest member of the DrivAx family, the Drivex Rq4.
Drivex Rq4 consists of a very efficient radial piston pump that is highly integrated and mounted directly on a synchronous servo motor. The motor is operated with a variable speed in both directions of rotation. With the pump for 4-quadrant operation, the direction of the volume flow and thus the direction of the movement of the actuator can thus be selected without additional directional control valves. A special feature of the pump is the possibility for dual displacement, but one after the other. Drivex Rq4 is available with 5 pumps from 19 to 250 ccm. Over the rated speed range of motor and pump, volume flows between 85 and 450 liters per minute can be continuously controlled. Of course, the pumps are combined with power-matched motors to match their displacement. The corresponding engineering is already included in the package. The pressure, which can also be controlled through the servo motor, can cover the range up to 350 bar. But what was that about dual displacement? The delivery volume of the Rq4 pump can be switched to an adjustable reduced size. What will be the effect? A smaller pump requires a smaller torque for a given pressure. With the knowledge of the duty cycle of the machine, this dual displacement can be used with a smaller sized motor and inverter. We not only save energy, but also costs in the investment due to the smaller components. Downsizing is the keyword here. Drivex Rq4 can be used in different ways. In the first case, the customer takes the Drivex Rq4 and builds his own system on it. More conveniently, our pre-designed function blocks can also be used. Those pre-designed control blocks map the Drivex Rq4 to the drive solution for a specific customer machine. They come with the necessary internal connections and additional auxiliary and safety valves. Different requirements due to processes such as forming, cutting, or moving are thus fulfilled in the best way without the user having to spend a lot of time on engineering. The motion axis is then completed, for example, by a linear cylinder as an actuator. Of course, this cylinder can also be included in our package to complete the system. For new machinery, we see field buses such as Profinet, EtherCAT, CAN, or Circos as the interface to the inverter for controlling the servo motor. For retrofit in existing machines, however, analog control can also be interesting. In this way, the function of a variable displacement pump or a control with servo valve can often be replicated elegantly and energy efficiently. With these technical possibilities, the applications are naturally also diverse. In production technology, drives are used for forming, cutting, or moving workpieces. In energy technology, actuators are used to control azimut or pitch in wind turbines or for adjusting the power output of turbines in hydroelectric power plants. Now, that was a lot of abstract information again. Let's go back to concrete applications and machines. DrivAx PSH and DrivAx CSH are our solutions for forming presses and drawing cushions. In these systems too, force, speed and position are controlled directly by the servo motor and pump. Throttling losses due to servo valves do not occur. In DrivAx CSH, a large part of the energy from the drawing process is fed back into the system instead of being lost as excess heat. Here is the data from a real design for a forming press with drawing cushion. This plant produces components for white goods, such as refrigerators, ovens, and washing machines. The design data for a machine with conventional hydraulics are compared against the results with DrivAx PSH and DrivAx CSH. Total energy consumption with the same productivity is reduced significantly less than 40%. The operating costs also decrease accordingly. Less energy also means less excess heat. Less than 1/3 of the amount of oil is needed for the management of fluid heat compared to a conventional system. Another valuable resource will thus be saved.
So we have seen that a switch to servo hydraulics is particularly worthwhile if the machine cycle includes many pauses, long pause times, or partial load ranges. In addition to new systems, retrofit solutions are also highly cost-effective, as integrating DrivAx drives into the machine layout is not rocket science in general. So, you're interested in our DrivAx family? We will be happy to help you with any questions you may have about your retrofit design, but also, of course, your new system. So, your key takeaway: the hydraulic drives of tomorrow are highly efficient. They simplify the system both in terms of design, installation, and commissioning. In addition, our DrivAx servo drives are characterized by reduced fluid volume and almost wear-free operation. Voith is your partner for the modularization or realization of your machine due to the many years of experience with servo hydraulic drives and modular system designs. If you have any further questions, please feel free to contact us personally. Our contact information are available here. Further information can be found on our website and on the datasheets, which are uploaded there. So, we hope that you enjoyed the insights into our portfolio of servo drives and look forward to our next project. Thank you for your attention.
Thanks for your interest and goodbye. I look forward to the next challenge in your project. Stay healthy.